Today we are going to be looking at inequalities, and I'm hoping this is a review, but just in case it's not. An inequality is a mathematical sentence comparing two expressions. So we've got two mathematical things, like look down at example 1, x plus 8, and then there's this inequality symbol and then -3. We are comparing x plus 8 and -3. The inequality symbol indicates which one is bigger. Do you guys remember the alligator? Did you learn the alligator? So the alligator eats which thing, bigger or smaller? Bigger. When I was younger, they taught us Pac-Man, because Pac-Man was a big thing then. So when we had these symbols, we made them into Pac-Man. Now I think you guys try to make them into, like, alligators. But you don't need to draw teeth anymore. We can avoid drawing teeth. So this first symbol is the is less than symbol. If you see this symbol, it means is less than. The next one is greater than. The next one is less than or equal to. Notice the line underneath the symbol. That's indicating that it could be less than or it could be equal to. And then the next one is greater than or equal to. First thing we're going to do in example 1 is decide if we were to plug -4 into the inequality. Is -4 a solution? Does -4 work? Does it make a true statement? So let's plug -4 in there. -4 plus 8 is greater than -3. And I'm going to put a question mark because I don't know yet. So what is -4 plus 8? 4. Is 4 greater than -3? Yes. So that means that -4 is a solution. It is one of the values of x that works in the inequality. The next one, we would do -4.5 times -4. And we want to know, is that greater than or equal to -21? What do you get in your calculator? Positive 18. Is positive 18 greater than or equal to -21? Yes. And someone in third hour said, well, it's greater than, but it's not equal to. It doesn't say greater than and equal to. It says greater than or equal to. So it can be greater than -21 or it could be equal to -21. Try the next one on your own. Plug in -4, see what you get. Okay, so if we plug -4 in, 2 times -4 plus 1. 2 times -4 is -8. That would give us, oops, I forgot a negative. There we go. -7 is less than or equal to -7. Is that a true statement? Is it? Yes. So -7 is equal to -7, so it fits that scenario. Okay, we are going to start graphing inequalities. I wanted to give you a couple of examples. So in your notes, it has these examples drawn in, and I'm going to write what these inequalities are. So next to your notes, write down what these are. This first one is x is greater than or equal to 1. The next one, x is less than or equal to -2. Before we write down what the third one is, I want us to talk about these first two examples. X is, X is the shaded stuff. X is all of the possible numbers that are greater than or equal to 1. So notice 1 is filled in because x can be 1. X could also be 2. 2 is greater than 1. 3 is greater than 1, and all of the decimals in between. So x is greater than or equal to 1 is a filled in circle shaded to the right. All of the numbers bigger than 1 are shaded in. The next one, x is less than or equal to -2. X can equal -2, so -2 is shaded in, and anything smaller, like -3, -4, -5, anything to the left is a possible value of x. What do you notice that's different about the third one? It's not shaded in. The -1 is not shaded in, so it's going to be x is greater than -1. Notice the numbers bigger than -1 are shaded in, but -1 is not shaded in. So x can't be -1, but x can be anything bigger than -1. Okay? Turn the page and let's try to graph some of these on our own. Okay. Before we graph, I want you to consider a few things. First, you'll want to consider, does x equal the number? If it does equal the number, then x is included in the solutions and you use a shaded circle, a filled in circle. If x does not equal the number, if it's plain old greater than or plain old less than, then we use an open circle because we're not including that number. Which direction should we shade? If it's greater than, we shade the bigger numbers. If it's less than, we shade the smaller numbers. Here's a hint for you. As long as the x is written on the left, if it's a greater than symbol, use that symbol like an arrowhead. Turn that into an arrow and it points which direction you need to shade. If it's a less than symbol, make that an arrow. It points which direction you need to shade. As far as what numbers to put on the number line, if we're doing x is less than or equal to -3, I like to see on the number line where 0 is. So put 0 on the number line. Would -3 be on the left or on the right of 0? On the left, so let's put -3 here, and then maybe if you want to put like a +3 on the other side, the projector will catch up in a minute, I'm sure. I do want to see 0, so I can tell that you at least have the number in the correct location compared to 0. You don't have to put these 3 numbers. I want you to put the numbers that make the number line make sense to you. So if you want to put 0, -3, and then maybe -4, -5 kind of closer, you can. I want your number lines to make sense to you. This says x is less than or equal to -3. Is x equal to -3? Does it have the equals line? Yes. So, because we have the equals line in this inequality symbol, we fill in that circle. Okay, x is less than or equal to, so we can make that into an arrow, and that shows us which direction we need to shade. Because it's less than, we need to shade all of the numbers that are smaller than -3. The next one, I'll put 0 on the number line and 7. You really only need 2 numbers on there. I want 0 on there and I want the number on there. If you want to put another number, if you wanted to put like -7 over farther on the left, or even if you wanted to do like -1, whatever makes your number line make sense to you. At 7, do we need an open circle or a closed circle? Open, because x is not going to be equal to 7. X is only going to be greater than 7. Now, where on this number line are the numbers bigger than 7? To the right. And that hint, as long as your inequality is written with the x on the left side, that symbol becomes an arrow that points which direction you need to shade. So take a moment and try those 3 graphs on your own. In example 3, we need to graph each inequality. Now, I feel like we're doing pretty well with this. The only reason I put example 3 on here is that example 3 has some kind of unique looking problems. And I don't want these to throw you for a loop because there's the same kind of problems we've just been graphing. The first one says y is less than or equal to 25. The only difference here is 25 is a slightly bigger number than we've been using, and it says y instead of x. We can use any letter we want. We could say r is less than. We can use any letter in the alphabet. So just because it says y does not mean it's any different. So I'm going to put 0, 25. If you want to put negative 25, it'd be like over here, kind of off my graph. It is a filled in circle because we're equaling 25 and shaded to the left. Okay, super easy. Okay, that's like the messiest graph I've done so far. How about the next one? Someone read the next one to us. Go ahead, Eric. 2 is less than x. How is this problem different from the other examples we've done? On the other ones, the variable is first. On this one, the number is first. Right. So when the number is written first, I want you to rewrite it with the letter first. Now, this is where the alligators come into play. What is the alligator eating in the original problem? The x. So you want the alligator to be eating the x. Once you've rewritten it, completely ignore the original problem and graph your rewritten problem. So now we need 0, 2, and if you want, negative 2. Open or close circle. Open, shaded to the left or right. My zeit? Is that what I heard? The trick with the symbols pointing the direction that you shade only works if your letter is written first and your number is written second. So keep that in mind. If you see the number written first, you have to switch it around. So try the next 3 on your own.
All right, let's go over the last 2 examples. We have negative 3 is greater than y. What do I need to do with the variable and the number there? I'm going to switch it around. So when I do that, I'm going to put my variable on the left, my number on the right. Which number in the original equation is being eaten like the alligator? Which, the negative 3 or the y? The negative 3 is larger. It's being eaten right now, so I'm going to switch that sign around and make sure the negative 3 is still saying that it's larger. So when I read that, it says y is less than negative 3. On my number line, I'm going to do 0, negative 3, positive 3. Am I going to have a closed dot or an open circle? Open circle at negative 3. And I'm going to shade to the left or to the right. Everything less than is to the left. Last example. 1 is less than or greater than x. I'm going to go ahead and switch my variable. Put that on the left and my number on the right. So my new equation is going to read, after I flip the sign, x is greater than or equal to 1. On my number line, I have 0, negative 1, and positive 1. Do I have a closed dot or an open circle? Closed dot at 1. And which direction am I shading? Greater than or equal to? Left or right? To the right.